Hello everyone, my name is Katie, and for my Module 1 presentation, I am going to be going over question 2. So I'm going to briefly read so we know what question I'm talking about, and then we're going to go into my examples. Madison has made up her own method of rounding, starting at the rightmost place in a decimal number. She keeps rounding to the value of the next place to the left until she reaches the place to which the decimal number was to be rounded. So, using several examples and using the example provided, we need to figure out, was Madison's theory correct? So, I'm going to use my phone as a placement. So this is the number we're starting at, 3.2716. So what Madison is doing is looking at the rightmost number, and she's going to the left until we get to the 10th place. So 6 and 1, 6 is equal or greater to 5. So then we drop to 3.272. 2 is not greater than or equal to 5, so it stays a 7. 3.27. The 7 is equal or greater to 5, so the 2 is going to become a 3. So how I did the problem was I went through the examples like this, exactly how Madison would have went through them, and then I took how I round. So I went back to the first set of numbers, so the 3.2716. I know we're rounding to the 10th place, and I know the 10th place is the very first number to the right of the decimal. So I know that when we round to the 10th place, we look to the 100th place to round. So I looked at the 100th place, which is 7, which is, as we found out down here, greater than or equal to 5. So I know this 2 would become a 3. So I knew rounding it would be 3.3. So then I used multiple examples. I used 3 examples to determine if this was correct or not with the examples I provided. So first, I did 5.173. The 3 is not equal to or greater than 5, so it just stayed to 571. 7 does round numbers, so we turned into 5.2. So again, I went back to the first one, 5.17, rounding to the tenths. I know that 7 rounds, 5.2. So for this one, again, Madison is correct. So then we move on. 2.8742. Now 2 does not round, so then we're left with 2.874. 4 does not round. 2.87. 7 does round, so we end with 2.9. Again, back to the top. 2.87. 7 does round, so this would become 2.9. So I'm now 3 out of 3 examples that Madison has got correct. But what I was doing was randomly typing numbers and testing Madison's theory. Now for all 100% right now, Madison is correct until I got to the last number that I randomly typed in, and I found the flaw in Madison's system. 6.3451. 1 does not round, so we are at 0.345. 5 does round, and it turns our 4 into a 5. We're left with 6.35. 5 does round, so we're left with 6.4. Now, when we do my theory and go back up to the first number, 4 does not round. So for the original number to round to the 10th place would be 6.3. But because the 5 turned the 4 into a 5, we ended up getting the wrong answer. So the flaw in Madison's theory is when a 4 gets turned into a 5 and it throws off the rounding process. So it is correct. It was correct 75% of the time, but it is not 100% effective, which means that it is not a theory I would recommend to a student or for you to teach to a student. Thank you.